assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Hello everyone, this is Ricky. We're working on problem 49 from chapter 22, and we're going to be determining the numbers of unpaired electrons for each complex ion. Alright, so first let's write out a general schematic for how to approach these problems. Determining number of unpaired electrons. First, we want to determine charge and number of d electrons in metal. Then we have to determine if ligands are strong or weak field ligands. Next, draw electron config and count. So not too bad, right? Okay. So first up we have RhCl6 with a charge of -3. So first off, let's determine the charge of the ion. So Cl6, that's 6 times -1 equal to -3 plus x, x being the charge of the metal ion, and we get x is equal to +3. All right, so now we got the charge. We can determine the number of d electrons. All right, so we have rhodium, which is, oops, so rhodium +3 with an electron configuration of Kr, 4d, for D6, oops, I don't know what happened there, 4d6. All right, next we have to whether these are strong or not. And just looking at our textbook, we can see that the chloride ion tends to be a weak field ion. Weak field ions produce high spin complexes. And high spin complex have the same number of unpaired electrons as the free metal ion. So even though this is enough information to question, let us draw out the electron, the crystal field splitting diagram. 1, 2, 3, 4, 5. Energy 46. 1, 2, 3, 4, 5, and 6. So it has 4. Complex has 4 unpaired electrons. 1, 2, 3, 4. All right. Next up, COOH6 minus 4. All right, so let's determine what the charge of the ion is. So Q for charge plus 6 hydroxides with a charge of -1 is equal to -4. Q is equal to +2. So we have a cobalt +2 ion, which has electron configured of a R3D7. Hydroxide tends to be a weak field ligand. Weak field, high spin complex. Star diagram. 1, 2, 3, 4, 5. 7 electrons. 1, 2, 3, 4, 5, 6, 7. And we're left 3 unpaired electrons. Then, last but not least, cis Fe N2 NO2 2 plus. All right. Graduating charge of the free metal ion. Right. So Q for charge plus 2 times 0, because ethylene diamine is neutral comp. And then next up, plus 2 NO2s, which have a charge of -1. And we get with an overall charge of +1. So that means Q is equal to +3. That means our iron has a charge of +3, and it has an electron configuration of argon 3d5. Now we want to look at ligands, and both diethylene and NO2 minus are strong field. Ligands going to be meaning that this ion forms a low spin complex And low spin complexes have fewer electrons relative to the free metal ion. So we need to keep that in mind when drawing our energy splitting diagram. Five electrons, 1, 2, 3, 4, 5. Thus, we only have one unpaired electron. Let's help someone else.